Software-defined network. Software-defined networking is a revolutionary approach to network management that enables dynamic, programmatically efficient network configuration to improve network performance and monitoring. SDN is designed to reduce the complexity in static and inflexible network architectures by using a standardized platform that provides a centralized view of the entire network. SDN architecture decouples the network control and forwarding functions, enabling the network control to become directly programmable and the underlying infrastructure to be abstracted for applications and network services. This separation is achieved through three distinct planes: the data plane, the control plane, and the application plane. First, the data plane, also known as the forwarding plane, is responsible for handling packets, moving data packets from place to place. It makes decisions based on protocols such as IP and Ethernet and is concerned with the actual process of sending and receiving data. For example, when you send an email, the data plane of your network takes responsibility of moving your email data from your device to the recipient's device. It does this by forwarding the data packets through switches and routers. Next, the control plane. The control plane is the brain of the network. It makes decisions about where traffic is sent. In traditional network architectures, each router has its own control plane. However, in the SDN, the control plane is centralized. This means that one central controller dictates the traffic flow across the entire network, making the network more manageable and flexible. Finally, the application plane. The application plane is where all network applications that interact with the SDN controller reside. These applications instruct the controller on what to do, and in turn, the controller manipulates the network according to these instructions. A real-world example of software-defined networking is Google's B4 project. Google uses SDNs to manage its data center networks. The B4 project allows Google to control the flow of data across its network, ensuring that bandwidth is used efficiently. This is particularly important for Google as it needs to manage a vast amount of data across its global network of data centers. Another example is AT&T's Domain 2 initiative. This project aims to transform AT&T's network into an SDN with a focus on reducing costs and increasing efficiency. By using SDNs, AT&T can automate many of its network management tasks, reducing the need for manual intervention. So remember, software-defined networking is a transformative approach to network management that separates the network into three distinct planes: the data plane, control plane, and the application plane. The data plane is responsible for moving data packets, the control plane decides where traffic is sent, and the application plane houses the network applications that instruct the controller.